Guess what day it is?
Good afternoon.
Good afternoon.
Hey,
Hi. Happy to be here.
oh, it's good to have you. Thank you for agreeing to join us today. Today's episode all about Adrian. You clicked the wrong button. At least it wasn't the red one this time. So
It looked like the dark background, but it was the timer again.
What does this button do?
what does this button do? Welcome to our live audience. Today's all about coupling and cohesion. There seems to be a cohesion problem with that button right now. So just want to take the comment off screen so we can see our names. Ferry, how are you doing?
I'm good.
Excited? Nervous?
Well, a bit nervous. I've done a few streams on this topic myself, but on a more broader spectrum, so static analysis as a whole. But while preparing this, like, you can go in depth. I mean, there's so many metrics. So I think it's nice to just put a magnifying glass on these two aspects, which people are talking about a lot, and I'm sort of wanted to do some streams about it myself. So it's great that I can do it here now.
Awesome.
There's a lot of talk, but then, like, can you actually, it's quality, but it can be quantified to a certain extent. So I think, and I'm sort of, for me, I got to know metrics when I was studying software engineering. And well, basically we had this interesting thread where you tagged me today, and I realized more and more that there's a lot of people just not aware even of these more scientific aspects of software engineering. So I think it's good if we can bring some extra awareness there.
Probably this is then about software engineering. I think most people aren't aware that software engineering still has a lot to do with science and thinking about things and theories, and we don't embrace the theoretical stuff oftentimes. Let's say we build upon gut feelings instead of numbers quite often, because it's the easier way, especially in the if we want to rush towards a deadline. It's always some preferable way of so many companies. Yes. So
Ferry, you mentioned you stream. Where do you stream? Let's get the links out of the way in the beginning.
I did a few on StreamYards as well, and I did them on LinkedIn only so far.
Okay.
So if you go to my profile, you can find recordings of those and some clips as well.
Cool.
And I will be grabbing some of that info, like the data, the analysis I did. I can probably use that in this stream as well as some examples. So
okay, here's Ferry's LinkedIn profile. I'll just do a quick intros. Ferry, I did notice that you just did something. I don't know whether you just moved away from the microphone, but your microphone quality just degraded a little bit for like 30 seconds.
Mine?
Yeah, no,
Ferry.
yeah. I don't know whether that's software related or hardware related. Just pointing it out.
If it keeps happening, I'll just dump the headset. Usually the mic is better there, but sometimes Bluetooth, I don't know. So I can dump it.
Dear audience, can you understand very well?
Yeah, give us a one in chat if you can understand Ferry.
Understand.
Yeah. Let's do quick intros. So as always, if you're looking for mentors or fellowships regarding engineering culture and leadership in engineering teams, Adrian and I started these streams as part of our sort of extension to our coaching and mentoring that we do. You'll find us on the links below. You don't need to be a beard to become our client, although we do have a huge sort of millennial audience, and both of us have a heavy PHP background, so I don't think it's mandatory, but it's an interesting tidbit, and online gaming background. You'll find me on Crafting Tech Teams. Adrian, you'll find on Stackable CTO. Adrian covers more strategic aspect, working with business owners and CTOs on more strategic aspects of engineering culture and everything that goes with it, about how to do X in my company, because my company is old school and special and traditional. And I work primarily with tech leads, engineering managers, and CTOs in startups. I do have to emphasize the CTO in startup because it's a more tactical position. Yeah. Ferry, do you work as an employee? Are you more of a consultant? Are you
I'm a consultant. I'm freelancing now for 8 years. I always say .NET is my fatherland and C# is my mother tongue. Been doing a bit of kind of PHP in the past, but still like C#, and that's most of the examples I will show are coming from .NET. Also, because unfortunately the stacks are not as mature everywhere. But I'm also moving more into coaching teams, helping teams build better software faster, becoming more efficient. So from the technical perspective, but also the process perspective. So,
do teams come to you directly for?
That's still a work in progress.
But I mean specifically the people you do work with as a consultant, do they come to you directly for coupling and cohesion advice, or is that like secondary? Is that more fundamental? How does the coupling and cohesion conversation happen with people that are paid clients of yours?
Well, I don't have that many clients for that yet, because I've been doing freelancing till last October, and I noticed that I have a big interest in this, and B, I have a higher awareness of these topics. But it's not only the technical side; it's also the process side. So the idea was I could sell like a due diligence or an assessment, and that would be an entry point. But you know that as engineer in the past, selling yourself is a different ball game from building software. So I'm still learning there. So look, like this appearance is part of that process as well.
But you have already streamed, about this topic, right?
Yeah.
So you streamed about NDepend, you streamed about how was it the other thing? 𝐤𝐶𝑖𝑛. I haven't seen 𝐤𝐶𝑖𝑛. That would be interesting for me actually. But there wasn't there a third one like or something? No, I can't.
I mean, I generally use 𝐤𝐶𝑖𝑛, SonarQube, and any kind of sort of homegrown tool in the PHP ecosystem or TypeScript ecosystem. There are quite a few tactical tools, especially for static analysis, but very rarely for what Adam Thornhill, the CEO of 𝐤𝐶𝑖𝑛, calls forensics, right? So particularly Git repository or Git history forensics, where you say, and a good example of forensics is this file has very low quality, and its maintainer has left the company. And 𝐤𝐶𝑖𝑛 sort of makes a prediction on who left the company because they have no longer, they haven't made a commit for the past 6 months, or they haven't made a commit for the past 4 months, or they have lost access to the GitHub repository.
Yeah.
Right. So that's a very good heuristic to see. Okay, that's a hotspot. There's going to be trouble whenever we need to touch that, which means that all components which are heavily coupled to that hotspot are also affected. And then that's a very good heuristic for finding trouble areas.
Yeah. Yeah, that's why the coaching really shines, because it takes into like the behavioral and the time dimensions and the behavioral aspect. And I haven't seen any other tool doing that. A lot of the technical tools are often on a lower granularity level.
Yeah, SonarQube, for example.
Yeah, but this is more like classes, methods, and what I really like about complexity. But what I like about NDepend is that it also allows you to go to the more structural, architectural level.
Okay.
And I mean, I haven't used a lot of tools in different languages. I know it has a version for Java and C++ as well. So they do have the same tool sets for these languages. But to be honest, I'm clueless in the Python domain or TypeScript. What tools you have there to do such things, if they're even there.
I've seen oversimplified ports of NDepend, but usually they don't capture the sort of, in languages that are not C-based, that do not have packages, it's very difficult to translate it over, right? So C# seems to be in that sweet spot. Already with PHP, with namespaces, where there's a certain forced cardinality with how the file is structured, with how namespaces are structured, there's already an issue where the visualization doesn't make topological sense. It's pretty, but it doesn't capture the same richness of information as the NDepend one, just because of the ecosystem.
Yeah. So do you know NDepend well, Dennis?
I mean, I've used it, but primarily I've used it as an inspiration to find similar tools. NDepend is very good, and I'm also following, fluent assertions whenever it comes to, writing tests in C# and the C# ecosystem, because a lot of my audience is C# oriented by accident, just because of how I grew the channel with Milan and other content creators who happen to be C# influencers.
You will be assimilated.
Where do we need to? So let's assume that we need to discuss, let's say, the atomic pieces first before we go into more complex matters. What are the, if I say coupling and cohesion, is that one concept? Are those two concepts? Are those two concepts separately and then another third concept together? Because everybody talks about coupling and cohesion as this one thing together. It's very rare. It's sometimes you see coupling, but you never see cohesion on its own. Like very rarely. My TDD oriented or TDD biased network might talk about cohesion, but generally I see coupling and cohesion mentioned in the same sentence. So how do we start the definitions? What's coupling and cohesion?
I would start at cohesion, because generally this is something you do on the class level.
Nice.
And essentially a class with high cohesion is also highly coupled.
Yes.
To an extent, because like all the parts are highly related, i.e. cohesive. So they have a very strong dependency within the class.
Go ahead, Adrian.
I think what came to my mind very often when we've talked in the past about design principles and programming principles, and coupling and cohesion was mentioned. This is because it's publicly known as that. But when we discuss coupling and cohesion, we actually discuss decoupling and cohesion, because you want to have things which are cohesive, and you want to have things decoupled. And coupling and cohesion is a little bit of, it is for me misleading, because it's both about getting things more together. So if we talk about coupling, we talk about getting things together, so coupling them. But in reality, it is about finding the line. So if we want to couple or decouple things, and so it would be made more sense if you would call that basically cohesion and decoupling. That would make more sense, because this is the actual stuff we do in this case. But so the standpoint from why we're talking about this is that we actually want to measure coupling and we want to measure cohesion. So it is more the scientific area where this is coming from, but in the practical sense, we actually want to decouple and not couple. Couple is the bad word, because cohesion is the nice word for the coupling part in this case.
Yeah. The thing
it's hard to measure separation.
Like the coupling aspect, there's many ways and definitions for that. Let's go into that later. But what I wanted to add to that, if you start if you're gonna work on a class that's incohesive, you are gonna create a set of more tightly coupled classes. So if you turn the knob on one dimension, you will get a set of classes that is highly related because they're depending on each other to serve a certain purpose. So you could refactor a single class, and I think that's often what they aim at when you're doing TDD. While not changing the public interface, you can decompose it into a separate set of classes that fulfill a specific part of the behavior, which creates a highly coupled set of classes. You could put some interfaces in between to decouple a bit further. So in essence, I'm a bit inclined to say that set of classes is still sort of a highly cohesive unit. So that you want them to live together in the same folder, for instance, or in the same namespace.
Raoul is mentioning in chat that your microphone started to jitter just slightly.
Yeah, let me switch just over to the Mac mic and let's see how that works.
Okay.
Good old microphone problem.
Thomas has a great question. When it comes to this topic, do we always talk about object-oriented? We'll address that. Yeah. Ooh, that's much better. That's much better.
Okay, cool. Let's just stick with this then.
Yeah. So a question for chat first. Dear audience, how do you reason about coupling and cohesion? What words do you use? How does it come up in your workplace? Would you know how to explain it? Would you give it a try and dump in chat your best level of understanding right now? It's okay if you think it's wrong or if it's incomplete. We just like to know sort of from what angle you would be your interest lies, or how you would explain it. And Danny has a great example already. I think the difference is to what level each concept applies to, even though their meaning might be similar, as well as the positive negative connotation each of them carry. Yeah, so cohesion has a more of a negative connotation, right? So, as coupling has a more sort of necessity domain to it, right? So you only want to couple by necessity, but cohesiveness, there's something sticky about it. So you want to make sure that things belong together, right? So it is a more separating concern. But I would like to hear your take on this. Thomas mentions for decoupling dependency injection as a solution. But I would like to linger on this idea when it comes to this topic. Do we always talk about object-oriented? So, Ferry, you mentioned classes, right? So units of classes are like a cohesive unit. Yeah. What about languages where classes mean something else, or where there's an alternative to classes? For example, JavaScript, TypeScript, or the whole, let's say, React Angular ecosystem, which has a more declarative functional nature to it? How do you reason about it?
I think sort of let's leave out for now the more functional languages, because I'm not experienced enough in that part. I haven't seen enough of React, and it touches on the functional level. But if you go to the language level, which, let's say, TypeScript or JavaScript, you often still have a module out of which you export certain parts of the code within. Let's assume that you have a one-on-one mapping between a module and a folder. So you're exporting classes, variables, files out of that module, right? So there is a similarity there, but you can choose how to do that. I would be inclined to say, like, a module maybe is related to a namespace. So you have just a single folder with a set of files that you choose to export or not.
I would add something. When you think of React, so React is one of my main things. In React, you have functions, of course, primarily functional programming. If you do classes, you do something wrong these days. But you think more in components than actual functions, which means that coupling and cohesion is actually a principle or two principles you apply when you make decisions. Where are the boundaries for a component? What is a higher order component? What are normal components? What are subcomponents? And so, for example, as we went over the Storify app, we had those, or I created those folders which represents the components, and the components had subcomponents, and this was a form of cohesion in this case. So I wanted with this folder structure to have a cohesion in components, but decoupling so with other components. So components don't belong together; they should be isolated. And on this layer, you actually do that, because if you just take a look at plain JavaScript functions in this case, you would just see that, yeah, okay, but there is no, let's say, you can't say, hey, I have something like a class there. There is actually, so functions are very loose anyway, and this is the problem. So they look loose, but in reality, they are tightly coupled. And so you need to have an artificial architecture around that, which is one of the reasons why React, in my opinion, is so popular, because it does provide you exactly this for how to handle your functions. And this is a common pattern everyone understands. And this is, so I just wanted to add that in the context of React, because I think many of the audience right now are audience people are using React. So in React, React is basically all about coupling and cohesion. So when you work with that.
So would you say that the component would be comparable to, let's say, a class in object-oriented language?
I would
necessarily.
Not necessarily, but it is a form of, let's say, of entity. So I wouldn't call in the React universe, or let's say in the React thinking, a simple function is not really a entity. So of course you can have helper functions. This is something different. But when it comes to components, you have oftentimes at least a function, but then it's a component already. So you treat them as components. They have specific rules how to use them. So I would actually think and start to think about how to decouple and couple things on the component layer, and not necessarily on, hey, it's a function, I need to do what? So this is a little bit. So it should have some form of let's say,
I think a package or a namespace would be more applicable, right? Because it might have it might have JSX, it might have type definitions, it might have hook structures, default values for certain things, mapping rules.
But you can still do like a big component that's very incohesive then.
Absolutely. Yeah. Prop drill inappropriately, pull in a lot of import 12, 20 other components and just put them all into like one giant file. You can make a mess, no problem. You can make a mess anywhere.
So that's often from a metric standpoint also, like, there's a high correlation between sort of the size of a class or a component and things like cohesion.
Gene mentions, I think you got it inversed in good bad. So that was my prior comment regarding sticky and regarding cohesion being the sticky thing and coupling being together. Danny mentions, so cohesion applies to, say, a function or a module. Yeah, a module is also a very good concept for a component, for what we would call a component in React. You want the code in there to be cohesive. It's somewhat related to SRP, the single responsibility principle from Solid.
That's what indeed also I think article on NDepend refers to single responsibility principle. So if there's many reasons for a class to change its state, then it's probably serving different responsibilities.
We have some attempts at definition. So John John Jean mentions coupling is proportional to how hard it is to use the same code in another context. Interesting. And then he mentions cohesion is how close each others are parts of the code that are used together in the workspace. Okay.
Yeah, but like sort of cohesion, I could still put a lot of code together in a single class, but they're very close together. But that doesn't necessarily means that the class is cohesive. So the sort of the distance of
so
the
used
code.
together does not imply appropriate locality. Used together might actually be an anti-pattern if it is not cohesive. Or does
Yeah,
it come from...
just like putting it together in a single class. As like there's probably then if you use all those parts together, yes, you're right. But they
together
can be,
all at the same time for the same reason.
Yeah.
Not sometimes A and B and sometimes C and D and sometimes D and E and sometimes B and A and sometimes D and E, right?
Exactly.
But all of them together all the time for a small handful of use cases, rather than it just being packaged together accidentally. And then there's some lines connecting, but there are more misses than hits. That would be bad cohesion.
Yeah, I think I can sort of, if I show some things in NDepend later, sometimes it's very obvious visually just looking at a dependency graph of a single class, for instance.
Yeah. Gene, thank you. That was very useful.
Yeah, and he's confirming that.
Thank you. 𝐶𝐜𝐡 mentions React function classes. State is also part of the conversation. Then pardon my
state.
French.
Yeah, the interesting part is that state. If you use state appropriately, well, so then it actually helps you to fulfill the let's say to do a good decoupled architecture and get things together which are actually belonging together. Because what we've seen quite often when we reviewed React, projects, we had the problem that, or saw the problem that you have often these very large components, and oftentimes those randomly, how can I put it? So it is a little bit like you have a chain of components, and somewhere in the middle part, suddenly components start to pull data from a database and react differently to other and just create side effects you don't want to have. And state does help you to create or to keep the idea of the higher order components, which takes care of those things and then passes the state down to the components so that they can take responsibility to display data and maybe send back data as a mutation. And then you have a clear architecture there. So this is one way of doing that. And a state or state management, especially state management like Zustand or Recoil, are really helpful in those things to design a well-structured architecture which is testable as well. This is often a problem that React applications which were not TDD-driven developed, that they are actually not testable anymore.
Because they're not cohesive. Because there is no cohesion, so everything is actually...
There's random coupling.
There's random coupling.
So the state then, I don't know that much about it.
You started that thought, Adrian, with... You mentioned things that belong together. But I think it sounds like the proof is in the pudding. What does it mean to belong together? Ferry, like for two classes to belong together.
Now we're coming in the definition territory.
Yeah,
I'm curious about the audience if they can name metrics that are used to measure either of those concepts.
Okay.
So if you know a name of a metric, dump it in the comments, because I'd like to know sort of what the awareness is in the audience of the actual measurements.
Okay, so audience, it's time to participate. One in chat if you're game. So we want to know what metrics you know to measure either coupling, cohesion, both, or something adjacent to the concept. The name of the metric. You can just dump it down, brain dump in chat. If you have several, just dump them down in chat so we can put it on the screen.
That's one.
And while that's coming in, we do have a little bit of delay with chat, usually like a minute or two.
There's something like 𝐓𝐞𝐜𝐡, but I'm not sure if this is something.
That's the one I'd like to explain. There's a few different ways to measure it, but let's see if some other...
I don't know 𝐓𝐞𝐜𝐡, so I'm glad I'm about to learn something new. So what's 𝐓𝐶OM? LCOM.
Actually teach you something there. It's actually lack of cohesion methods.
Interesting.
So it's measuring the inverse. So there's
hold on, is it you mentioned lack of cohesive methods. Is it LOCM or is it 𝐓𝐶OM?
No, lack of cohesion of methods.
Lack of cohesion of methods. Okay, I see. Okay.
There's a few ways to measure it. So there's some variants on it. I've been doing some research on it. It's like nobody has any idea how to sort of measure coupling. I'm curious about that one because those are fairly. So for me, it's like, okay, if you hear what it is, it's very trivial. A few at least.
Well, there is of course connaissance, which is not directly what we need in this case, but it's related to that.
Yeah, it's qualitative, not quantitative. Yeah. So if you want quantitative metrics, I mean, you can measure number of imports. You can measure distance. I see Vlad Kononov talk about sort of distance and strength as metrics to coupling specifically. Right? So how strong is the coupling and how far away is the thing you're coupled to? Again, how far away then becomes this architectural concern, which usually brings in the topology of the project, right? So if you're using clean architecture, you might say, okay, how many layers away is this? Or how many feature hops away is this? Or how many layers of indirection away is this? And then you basically have a project-specific definition for distance.
Yeah, I haven't seen tools using those in combination. I've been thinking about that myself. If you have two components which have a high coupling, so let's say component A is consuming a lot of information or functions of component B, they're very distant, they might be too far out, but that depends on the incoming coupling from other components as well. So basically, because that's basically two simple definitions of coupling, and it's not necessarily wrong. There's no wrong or right here. It's really depending on how you like where is the code in the architecture. So you have there's afferent coupling and efferent coupling. I find them very sort of hard to distinguish. So I think fan in and fan out are easy to understand. Fan in is basically the amount of incoming dependencies. So how many types are depending on you, and fan out is how many types are you depending on. So that's that's very easy to count.
So it's provisioning side coupling and consumption side coupling, right? So it's I depend on 10 things, and my public interface exposes 4, or it might give meaning to 4 different concepts that you need to be coupled to at the same time.
But like code that is like, let's see, there's this comment. Maybe that's interesting.
Yeah, but Danny,
it's long.
Math module within a module cohesive.
I would read it. Danny Gomez-Franco says, note also cohesion is closely related to your domain. If I'm implementing JS math module, all the little functions within the module are cohesive. If I'm implementing a IBAN, so international banking account number, I think, checksum calculator, and I split the different steps in individual functions, I'd say cohesion would be lower, ? Especially considering they don't have any use of their own. Not sure what 𝐓𝐶OM4 might indicate in these examples. Is 𝗪𝐶𝐿COM4 something special? So a measurement, or
I have heard of that one. I don't know what sort of the 4 refers to. I've researched too, but what I can say about, there's 2 things I want to say about this. For instance, the math module, you can expect that it's very simple to understand that is a low-level dependency. So that should have a lot of fan in, but it should not have any fan out, because it's like fundamental. Basically, it's just working on primitives. So that is a component where you expect a high incoming coupling and no outgoing coupling, i.e. it sits low in the architecture. Now the Ivan checksum, from a DDD perspective, I would say that's a value type.
Yeah.
You're just representing them. Even if
you don't want that to be cohesive, because otherwise it wouldn't be domain agnostic, right? You want a lot of different businesses to use IBANs, not just Visa.
Yeah, but you could embed these rules in that type. But the IBAN, that we could say, okay, that's still a string. So you have a private variable that's a string.
Stringly typed problems are generally different to reason about, because there's a linguistic component to it.
Yeah, you can say, okay, I split those 4 segments up because I need to do something.
Yeah. So it's the formatting part. It's the same with dates, right? Dates are also a stringly typed problem, and then you immediately get into these linguistic details of, well, is it still the same date format if I change the dots for commas? Is it still the same date format if I change the dots for slashes? Does the meaning change if I add slashes instead?
But if you, from a class perspective, how would you implement such? It's probably still one class variable which holds the data, and all these operations operate on that single instance variable. So your class actually has a high cohesion, because, and I will show you the definition of 𝗪𝐶𝐿COM, and there's a few others. But you essentially, all these methods are operating on that single field. So, there's only one reason for it to change. Basically, only the constructor is probably writing it, and the rest is reading it. Is probably not doing anything with it. So, from a cohesion perspective, it has a high cohesion or a low 𝗪𝐶𝐿COM.
Low 𝗪𝐶𝐿COM, yeah.
Because it has a low lack of cohesion of methods.
Oh, I hate inverted metrics so much.
Yeah.
Wait, so Carol Kreft mentions in a great book, Fundamentals of Software Architecture by Neil Ford and Mark Richards. Great book, by the way. There is a separate chapter dedicated to methods of assessing coupling and cohesion, including specific mathematic formulas. Right, so we already mentioned a few of these. I remember this chapter. Afferent and efferent and afferent coupling. Then there's cyclomatic complexity that we haven't mentioned yet. There's
duplication.
Duplication.
There's
there's law of Demeter, right? So how many hops or how deep is your dependency chain, depending on which direction it goes. How many arrows, how many dots are there, which is usually law of Demeter. What else is there on top of my head? So apparently 𝗪𝐶𝐿COM4, 𝗪𝐶𝐿COM5. I'm not sure what 𝗪𝐶𝐿COM4 and 𝗪𝐶𝐿COM5 are. A quick Google didn't give me
we can look them up and compare them
simple
to
definition. And one that I find really useful to do is the data cohesive with the behavior? That's what I like to sort of, as a qualitative metric, use in object-oriented languages from the concept of tell, don't ask, right? So am I asking somebody to perform an operation based on my data, or am I asking something for its private data structures so that I can perform an operation on it, right? So that would usually be a sign of lack of coupling, right? And perhaps 𝗪𝐶𝐿COM is the inverse to this.
It would increase 𝗪𝐶𝐿COM, because as soon as you start to expose that, you actually have another method that's referencing that private variable. Shall we just maybe jump into some of the definitions of 𝗪𝐶OM and maybe even 𝗪𝐶OM4, because like there's many ways of measuring it.
We have it on screen.
Sorry?
We have it on screen. We have the definition for 𝗪𝐶OM4 on screen.
Yeah, I had that. screen.
So
My
lack of
cheapest
cohesion-
employee helped me.
Lack of cohesion in methods version 4 is a metric that evaluates the cohesion of a class by constructing a graph of methods and attributes, then measuring connectivity to identify how closely related and focused the class's responsibilities are. Of course, now we'd have to know how exactly is it measuring the connectivity. Would you add anything here?
Well, it's sort of 𝐓𝐿COM4, even though I've heard of it, I've never really looked good at the definition because the tool, like NDepend's not measuring 𝐿COM4. But there's no formula here, right?
Not directly.
No.
Carol mentions, and if you don't care about maths, you can just check if your IDE supports 𝐿COM calculation JetBrains products to that via plugin. Yeah, there's also a lot of, you also have 𝐂𝐞𝐡 available to you. You might actually measure more complex measures like 𝐂𝐴𝐷 So 𝐂𝐴𝐷 are usually a mix of quantitative and qualitative measures to give you a little bit more of a pragmatic, this is this kind of smell, so it has this kind of solution, rather than just having the abstract metrics objectively.
So what 𝐂𝐿COME does, it basically takes away the interpretation for you.
Yeah,
Because
yeah.
it still uses metrics on the water, but it will just say, okay, there's a cohesion problem with this class.
Yeah,
But
or
it
there's a
doesn't-
bumpy road. Yeah, or there's a long God method or a God class,
Exactly.
or
So
yeah.
it's not saying, oh, you have a cyclomatic complexity of 42 in this function.
Mhm.
So it's not mentioning it. So I think that's good because it does a lot of interpretation for you, and in general, especially if you combine it with their hotspots,
Mhm.
it's value. The numbers matter less.
It's meant to educate. You don't need to know what the numbers mean. It will say, right? So it will say, I flagged this commit because there's a bumpy road in this class. Prior to committing, cyclomatic complexity was 18. Because the class is flagged, because this file is flagged as a hotspot, as a critical spot, you made it go from 18 to 19, which is above the alert threshold.
It's the wrong direction. Yeah.
Yeah, so it's getting worse. So it was flagged and it's getting worse, and then that's the language 𝐂𝐿COME uses, for example. And I love that because it gives you that as a completely automated, very actionable and very clear pull request. It's code review for you, done by automation in human language. It's speaking. It doesn't measure like a linter would. It just says there's a problem here. This is what a solution might be. You can do these 3 things, and I flagged it because this is above threshold. And then it gives you 3 options to what you can do. You can split it, you can extract it. You don't need to delete stuff you just added. You can just split it into 2 functions, so you have 2 smaller complexity functions rather than 1 large one.
Yeah.
Then it will give you reasons for when that's good, when that's bad. And you can it's basically very educational. It connects you with the literature and the white papers that document things like coupling problems, cyclomatic complexity.
I think that's one of the problems of metrics because they're maybe a bit too scientific for many people, and the interpretation is hard because it's not always as I'm saying, like a high incoming coupling is sort depending on the context. So,
Yeah, and 𝗪𝗵𝗲 has 2 comments on that. Examples in this case. Do you have any examples right now where we could take a look at?
do you have any examples of when cohesion is a good thing? At what point does it become ugly and why? Of course, you can have everything. What is a why? I don't have what I can maybe show is in NDepend. We can open up some classes so we get an ID. NDepend has a recommendation about thresholds.
Let's go.
So we can just go in there.
Let's go.
Okay. I can maybe I should give a bit explanation about sort of the definition of just 𝐿COME.
Quickly, 𝗪𝗵𝗲 has another one we can include here as well, is the why. So he says we can measure everything, but why?
Well, the short answer is maintainability.
And why does and we need to be specific here. Maintainability in itself in a vacuum for an engineering department is not important. Right? So why is maintainability complexity important for a business?
Because if you don't take care of that, it becomes harder to change your software. Understand
Okay, cost of change, yeah.
Cost of change. It's also you introduce more risk of errors when code is more complex, harder to maintain.
That's cognitive load, right? So you need to have 10 editors open instead of 2.
That's cognitive load, not alone, but if it's harder to understand, it's also easier to introduce bugs.
Fair, okay.
So
that's accidental complexity.
This reminds me on our Tailwind session.
Yeah, definitely.
There we are again.
Okay. Yeah, bring it on screen when you're ready. Just let me know when I can put it on stage.
Well, I will first go a bit briefly over the definition. I think it's still interesting to just show what, at least NDepend, what definitions it uses for those two metrics. Let's pull it up. Where is it? Is it actually telling it here? It's not actually giving the formula, is it? Hang on. I have another one ready here. Here it's explaining. And then I can show it shows some examples. So let's just go over it. Crunch some numbers, and then I will just dive into an actual code base I analyzed in one of my other streams.
Okay.
And we can open a class with a very high lack of cohesion and a very low, so a cohesive and an incohesive class.
Awesome.
And I can also show that in 𝐓𝐞𝐜𝐡 because I pulled those.
Perfect.
Now let's get to the fun part.
The technical side. So
yeah.
Do you want to share my screen?
Yeah.
Sure. Yeah, go ahead. Yeah.
That makes it easier to share things then.
Okay, yeah. I need to share.
Otherwise, we need to describe it.
Yeah. I mean, we can share the link and then ask everybody to open it, but it's just going to be more complicated, especially with our audio-only audience.
Just open the...
Okay. Can I put it on stage? Is it clean?
Yes, I closed all my secret windows.
Okay. I'll just ask you to perhaps increase font size just a little bit for those of us who are millennials. There we go. Okay.
Let's see. Where is it?
I think that's sufficient.
Let's just look at that one because at this point I don't understand well enough the difference between those two, other than that 𝐓𝐞𝐜𝐿 has a range between 0 and 1, and the Henderson-Sellers has a range between 0 and 2, and that it's a bit more. It filters out more classes than 𝐓𝐶𝐜𝐿. So in 𝐓𝐶𝐜𝐿 you might have earlier false positives, so to speak. So it's harder to make a distinction. But what it does, so 𝐓𝐶𝐜𝐿 is basically 1 when there's like a high lack of cohesion methods, and 0 when there's no lack of cohesion methods. And it takes, for each field, it sums the methods that reference it, and we'll show an example later. And then it divides it by the amount of methods times the amount of fields.
Okay.
So let's just go to an example, then I will speak a bit better. So they give an example here. It's a very trivial example.
We need to bump the font size again, please.
Yeah. So there's here you have a number manipulator, which is just one a private field, and it has a few methods that changes it. So like all the methods actually change the same piece of state, and this is I don't think this is the best example because you can think of a lot of other scenarios. So I prepared another one, but let's do they actually don't do a calculation here, do they? They're not comparing it in terms of.
Well, let's do the calculation manually. I mean, they do. Yeah.
Here's the actual calculation.
Yeah.
So what they say, the number manipulator, you have 3 functions manipulating that single field. So there's only one field they go over, and there is 4 total functions because you also have the constructor.
Makes sense.
Yeah. But in this scenario, you have 3 fields and 4 methods. So let's just go back to it. You have 3 fields and 4 methods. 3 plus constructor.
It's constructor. Yeah.
Yeah. So that's hidden, but it's counted along. So that will get you to a higher lack of cohesion methods. Because 3 divided by 12 is 0.25, so that leaves this. Their recommendation is everything above 8 with 10 or more fields. So they actually say you should look at the context as well. If the amount of fields is above 10, then you really should start worrying because it becomes bigger as well. And they don't do the same for the Henderson-Sellers, I believe. Oh, that is. Yeah. So, but let's just.
So 0. I just looked at the definition. 0 means totally cohesive. 0 means this entire thing is one unit, and it does one thing all the time, regardless of how you invoke it.
Yeah, that's why I was with that IBAN. Like it's almost the same as that number manipulator. You might have a few functions, but they're all operating on the same state. But they're all changing the same thing.
Okay.
Maybe I can show a simple example I made.
Now it gets colorful.
Yeah, it's very colorful.
Let me open.
So, what are we looking at exactly?
Hang on, I'll just show you this one more example. I just made this sort of simple thing because, like, you had this example where you were either each method was changing one field or like a single, or they're doing 3 different fields, and I was like, okay, but what if we just a simple example where you have 2 fields and one is the age is changed by 2, but it's touched by multiple methods, and the other one is touched by 2 methods. So I was just sort of trying to figure out, manually calculating it and then verifying with NDepend what it would come up with. So in this case, for instance, you have 3 methods referencing age. There's 2 methods referencing name because like you're reading the name here and you're writing it there. So in total, there's 5 sort of method MF fields changed or methods changing or accessing fields. There's 4 methods in total, and there's 2 fields. So the outcome would give you 1 minus 5, which is these 2 divided by 4 times 2. So 5 divided by 4 times 2. So you come then to 1 minus that. So that's 0.375. So that's fairly low. The Henderson-Sellers ends up 0.5. Anyway, so I just created this as just to understand a different example where it's not just about 1 field or 3 very distinct fields.
Makes sense.
Now, let's go back to the other example.
So if my 𝐿𝐶𝐜𝐿 is above, let's say my 𝐿𝐶𝐜𝐿 is 0.9, what can I do to get it down?
Like,
without impacting behavior, functionality, right? So I just want to refactor it and get the number down.
Splitting it up is probably the simplest thing, because there's parts maybe acting on shared state, and there's parts that are acting on distinct pieces of state. And I can show you some examples how NDepend.
So using the name and age example that you just mentioned, that there was a mutation path and a formatting path, you would put the data with its appropriate mutator and formatter.
Yeah, for instance.
Yeah, so we had the age and the what is the other thing? There was age and name.
Name.
So you put the age in an age class and the name in a name class, and then
you could do that, for instance, but there was no reason to do it with this class
because it was sufficient.
Yeah,
but is that where we're going with this? So that reminds me of tell, don't ask. So the qualitative aspect of that is tell, don't ask, right? So don't give me your data, or don't hide your data and then force me to put the method into your your class that has the data as a private field, but instead encapsulate the data in a class, and so that the class then has the formatting behavior.
Yeah.
Right. So that you then have a formatted age, not the age that has a format method or a toString method. Right. So it'll be even lower cohesion.
Here you had no reference to the rest of the person. If you would have that, you obviously would have a different challenge. I mean, if you were referencing both in that formatting, I don't think this is the best example to I didn't really think about sort of the refactoring aspect. I would never write it.
In this example, the split is it looks too naive, right? So a developer will be skeptical to say, okay, well, is it worth splitting? Like, it's not really that messy.
So that's not really, indeed, like that low outcome is not really worth having a discussion about. So let's come back to this this colorful tree map, where you can use different levels to project metrics. So it's on the type level now. You could do the namespace level, for instance. You get different sets of metrics then. So namespaces used is like also coupling. So or namespaces using me. So that's like a fan in and fan out on a namespace level.
So just to our viewers and our listeners who might be watching this, who might be listening to this without watching it, what Ferry is showing is NDepend is showing us the code metrics view in NDepend. And if you've never seen that, it is a, I think this is called a topology chart, a tree map. If you've ever analyzed your disk space, it is exactly what that looks like. So it's a bunch of boxes next to each other that align into bigger and smaller boxes, and the biggest offenders are scaled from red to green on a given axis. And I believe the metric that we have chosen now is size by lines of code, and the color is by cyclomatic complexity.
Yeah, so let's change that to lack of cohesion methods. Lack of cohesion of methods. It's indeed it's a confusing one. So here by default, that's the recommendation is having a threshold of 8.
So
and 8 is red then.
So 0 to 10, 8 is red, 7 is yellow, 5 is green.
Yeah, 0 point. So it's because it's never gonna get above 1.
And just as a qualitative remark, half of the screen that we're watching is red.
Yeah,
give or take.
This is you're looking at a code base of 20 plus years old.
We're looking at NHibernate specifically. For those of you who among us who are C# developers, you know this code base very well.
And the Java developers, they might know Hibernate.
Yeah, because PHP developers as well. Doctrine is a direct clone of Hibernate, even though it diverged slightly in architecture.
Yeah, I guess that happens over time anyway, because you can do things in these languages.
But it's an ORM. We're looking at a very old, complex, and widely used ORM, and we're looking at its packages and classes from the perspective of lack of cohesion of methods in the context of file size or lines of code.
Yeah. So there you could see often a correlation if you also look at cyclomatic complexity. You see that the bigger squares are often also have a higher cyclomatic
complexity. Yeah. What decisions can I make off of this? Like if I'm a engineering manager, technical program manager, architect, if you open me this screen, at what point do I say, that's a problem? Like, well, what is the noise to signal ratio on this chart? Do I want everything to be green? Is there some other metric that I need to combine it with? Like, how do I extract insights and actions from this chart?
We're digressing a bit into something else, but it's a very valid question. And in my analyses, I actually often combined 𝐂𝐞𝐡 with this. Because
it helps you filter and prioritize.
𝐂𝐞𝐡 filters out. I probably still have that open somewhere. Because it takes into account the time dimension. So
I see you're logging in. Should we hide the screen?
I would like to ask a question to the audience in between. How many people of you are actually using NDepend, 𝐶𝐶, or any kind of tools to measure those things or similar things? Please answer just with a 1 or the tool you actually need for, or a 0 if you don't do it right now. That would be interesting. It's the cheapest poll we can do.
Yeah.
Let me log in at the same time in another window.
Great example.
Here.
Thomas mentioned 0, so he's not using any of the tools. We also had Carl here with us, Danny, Jean, Kaloyan. What tools are you using? What tools did you hear about but are not using? What do you run? What do you run? So maybe we didn't mention. Maybe the question is too vague.
Yeah.
If you have a pipeline that runs, what tools do you run in that pipeline that gives you anything that has a color, a green, a red, something that you would take seriously to actually go and change your architecture? What is that? Is it a linter? Is it the Airbnb prettier definition? What is it exactly that you use to measure code quality or coupling or cohesion, anything that you have running right now in your IDE, code base, etc. Raul mentions 𝗪𝗏 ? So I'm not sure whether that's a question about 𝗪𝗏 or whether he says he's using 𝗪𝗏, maybe.
I think that's a more common one.
Yeah. It also depends heavily on your ecosystem. What we're looking at right now is 𝐶𝐶. I love 𝐶𝐶.
It's quite expensive, so you need to have a good reason to do that on larger scale, which is well, you have one very early on, but
on large scale, I mean, 𝐶𝐶. I think 𝗪𝗏 is on the pricier side, but 𝐶𝐶 is quite accessible.
I don't know about the pricing model because these are open source projects, so these are free. I cloned them and put them on the mouth. But let's do a bit of a comparison between this and NDepend, because I think it will show the prowess of 𝗏𝐶, and it will show where NDepend has issues on that part, because there's a lot of noise there. So I think you can define the time range on which this is looking. So your hotspots, as you can see, they have a commit threshold here. And I believe, but we can go into the settings, by default, it takes a period, I believe, of a year. So it says which files are changed a certain amount of time. And so those are hotspots in terms of change frequency. So it looks at change frequency on a period from now till 1 or 2 years ago. You can't even go further back. So here you can see if I upper the commit threshold, then these files have been changed 7 times in the last year, if I'm correct, if that is still the setting, because I might have turned it to 2 because of the activity on NDepend, but that doesn't really matter that much. So this is just looking at change frequency, not anything else. And then it combines it with refactoring target. So it adds on other metrics. So that's what I meant with they take away a lot of the interpretation of the data because they're combining a lot of data. They're looking indeed in how many different people are changing this. Has it been changed by people that are no longer committing? So it's really doing a risk assessment of your hotspots that you need to refactor due to for different reasons. I think they explain it here. So.
And you can even match it to your work cadence, where you can link it up with your pipeline, your CI/CD pipeline, and then the CI/CD pipeline can tell you whether you just touched something that's a red hotspot.
Yeah.
Right. So you just made a change in a file that's red, and you made it worse, and it might actually block you from being able to merge, or it'll give you a bad review, and then it'll give you a bad machine review. Right. So It is a more architectural code review,
Yeah.
almost as if you were getting it from another human.
Yeah.
A feature, if you can just show it real quick while you have it open, it's under, I think, under team dynamics or architecture. They keep moving it around.
I don't. What do you want to show?
Architecture, the change coupling. Change coupling. There it is. Yeah, change coupling.
Yeah.
This is amazing. If you love data, this is amazing. Right? So what it tells you, if you hover over, for example, SQL command, what it will tell you is that every time you change SQL command, you also accidentally change all those other modules.
Mm-hmm.
So this,
So
it's immediately mapping the topology of your coupling outside of the cohesive unit. So SQL command is the how would you call this? The module that defines the boundary of cohesion. Right? So everything that is inside SQL command is about SQL commands. But the humans, the engineers who make changes to SQL command, half of the time they make changes to SQL command, they also make changes to that other thing.
Yeah, it
Right?
can do that. Yeah, it can do that in commits, but if you do issue tracking, it can even see which files were changed within
Which
the context.
issues. Yeah, it can then help you then overlay. And also, sometimes there's a signal to noise ratio here, and it can also help you filter them out by looking at a different time horizon or by looking at it from on a team level, right? So Bob and Steve are on the same team. When they do that, it's okay. But Ferry and Dennis are on a different team. When they do that, it's not okay, right?
Yeah.
So that you can even manage it on a team coupling level, right? So is my team touching stuff that is coupled without cohesion to stuff that another team is maintaining? And that is invaluable in organizations that are just beyond small, right? So anything beyond Dunbar number, 2 teams, 3 teams, 23 people, more than 17 engineers, that is invaluable because you see all the accidental coupling.
Yeah.
That's a very good point, actually. There we are actually at the boundaries again. So we will talk about who is allowed to touch what, but you're still working in a monorepository. So you can prevent people from making changes where they should not make changes, or they don't have the ownership of. This is quite cool. I have to say.
You can do code ownerships, I believe, as well. I mean, I have only scratched the surface from the hotspot level, but I wanted to jump into like one of the hotspots, and here you can see essentially rule violations. It mentions it, but warnings are like it has a set of rules, but it's not. So it's mentioning low cohesion, apparently with 𝐓𝐸𝐿Comm4, but it's not mentioning actual values. But it will give you hints how to fix it. But
and the how to fix it is most important, right? Because it immediately tells you you can't just go around extracting stuff. You have to make sure that this file has many things, and 10 out of the 214 things are messy, and you have to make an extraction in one of those messy 10 things, not the benign, simple stuff.
Yeah.
So that's really great.
So this module has more than 10 different responsibilities. Apparently, I don't know where it gets this number from. It would be interesting. Amongst its 214 functions, so it's huge. We'll dive do a bit further analysis on this one because
𝐓𝐞𝐡 draws boundaries on responsibilities on the things that it draws circles upon in the hotspot view. So if this file is a JavaScript file, it's possible it's exporting 10 things, or maybe it is exporting 10 classes, or maybe it has 10 different unique exports. Right? So usually it is the boundary of the module. So, but it is an estimate, right? So that it has X responsibilities that is in 𝐶ODE specifically interpreted in a very specific way.
Okay. Yeah, I'm curious. I'll dive into this a bit further. It does show you change coupling here as well. So you see that this file is often changing in conjunction with the loader.
Yes.
Which makes sense.
And that highlights a cohesion problem, right? If they constantly change together, either the coupling is inappropriate or they should be packaged together. Or maybe these need to, or maybe there's a third thing that is mutual, that doesn't belong to either one of them, that should be extracted for high cohesion, like an IBAN number. Like
So this loader, as far as I recall, is defining an interface that is implemented, I believe, by persisters. So any change the loader makes to that interface automatically has to be changed in all these persisters. But because this is the abstract base class, then often you see the change in these ones and not the subclasses. So that there's a ton of interfaces even, I believe. So this one implements, I don't know, like we'll see it. It's like 10 interfaces or something.
And what you just mentioned, that idea of having an interface for implemented by a base class, even if it's a base abstract class that is then being used for other things, that in itself is fine. That is the hallmark for hexagonal architecture, clean architecture, clean code. The problem is that it is located in files that are extremely large, right? So it is that combination of two problems that makes this a hotspot.
Yeah.
Because this one has 4,000 lines of code, which is why it's large and red.
It's big. It grew up. I think it's interesting. You can also see here, like who made the changes here. So there's many people who have been working on this. And you see that it exploded in complexity at one point in time.
But then it kept it again. Because people haven't worked on it, or the people weren't adding complexity anymore?
What do you mean, the flat line?
Yeah.
I think these are commits. So basically, there's been no commits to it.
Okay.
So here you had one.
I mean, just looking at the shape of the chart, it seems like this was an experiment originally, and then a large feature branch was merged together into what is now mainline. That's a merge.
Huge. Yeah. See, so
yeah, that's a merge.
If they would have had 𝐓𝐞𝐡 at that time, this is probably the point where it was already big, as you can see, but where the alarm bells should have gone off. Maybe.
This chart, the shape of this chart tells you that there was a large, long-lived feature branch that then suddenly got merged and the complexity got out of hand. This is normal. This is hallmark code scene forensics, right? Like this shape of the chart specifically.
So this is that's I haven't seen any other product. It's really great that these kind of things. Have you tried the AI refactoring that they introduced recently? Did you do any?
Not a fan. Tried it. Not a fan. Like it's not beyond junior level, right? So it doesn't. AIs are not very good at coding yet.
No, they don't structure. They can't really do like structure, decomposition, or these kind of things. Apart from decomposing in some functions. Yeah,
and it's very much. The one I saw a demo, but again, it was a demo. I haven't used it myself. But there's a new Copilot product that has context-aware refactoring in the IDE as an alternative to the what you would call resharper-like tools, right? So refactoring tools that are based on static analysis. You do that with an AI instead that is context-aware, but it's not there yet.
Yeah. And even if it's there, you do need to have a very consistent, like conventional architecture for AI to understand what it needs to do if you ask it to do bigger things. Because if there's no strong conventions, humans make a mess, AI will make a mess as well.
But it's an interface problem, right? Because I trust my IDE to write to my disk. I don't trust the AI to do so, right? So when I'm prompting the AI, there will be a moment of separation between what it suggests and me putting it on disk, which is a pause and indirection that I do not expect from refactoring tools. I expect my refactoring tools to just touch stuff and I'll undo if necessary. Right. So and we had a comment on this. So Danny mentions, so Gene mentioned ESLint, Prettier, and SonarLint. SonarLint I haven't used yet. And Danny mentions ESLint can report cyclomatic complexity, but other than that and tests nothing. Back when I was working at bigger companies, I was using SonarQube. Yeah, so SonarQube is definitely a chat, a audience favorite at the moment. I just wanted to mention this, Ferry, that from the perspective of refactoring tools, I want my IDE to refactor stuff, and then I want the IDE to run static analysis. And then if the static analysis shows that now after refactoring, it gives me a compiler error, I want the IDE to undo the step and say, I couldn't safely refactor it. Here's the reason why. An AI tool will not do not do those 3 steps. It will only do the first 2, and then it leaves me to clean up the mess, which is the part that I hate, because that's actually what slows me down. Right, so if I do right-click move method, if there is no legal move that it finds to not create a compiler error, then it won't let me move method, and it will tell me you can't move method because you need to extract the variable first, right? So it's creating a closure around a local variable. Introduce a variable first, introduce a constant, introduce a parameter, and then you can move the method.
I think I think that's because the AI operates on the text and not the and refactoring tools operate on the abstract syntax tree. So that's
on the AST.
That's where it's different. A little bit more on 𝐂𝐡, and then I'll answer your question on NDepend and show why that is much more difficult because it's lacking the time dimension. And then I think it's interesting to look at this incohesive class and maybe also look at a few good examples.
Would you use an intermediate question? Would you use NDepend and and 𝐂𝐡 at the same time? So do they have overlap, or actually do they serve different purposes?
Well, they have overlap. The overlap is, for instance, in these kind of things, like the where do I have it? So the cohesion, the complexity, that's what NDepend can calculate as well. 𝐂𝐡 is very strong on, as we said, the time dimension. NDepend, it can run in your CI doing an analysis each build. So it does have trend analysis. Yeah. So you can make it fail on regressions of quality.
Yeah.
It's very fine grained. So it's very customizable to your specific project, because if you turn it on by default, especially in existing projects, I will show you now, you get a ton of so it has a NDepend's built on what they call code query language. And those rules are built in code query language, and the rules are stacked. So you have rules that can query the output of rules. So they have a dashboard.
That's great.
And the dashboard has, for instance, quality gates, which you can run through your CI, and you can define what the quality gates should actually do. So here you can see the query. So here it has 3 quality gates failing, which are critical issues, critical rules violated, and depth rating. Now, the depth rating, it's a long story, so let's not go into how it calculates that. But I can also just look at the quality gates and here it opens up the rule. And it says, so it has a data set issues, and it says basically all the issues that have a critical severity, just give me those, and it will show you all the critical errors here.
So too big interface, too big types depend on too many other things.
Yeah.
Mutual, like circular dependencies between namespaces.
Yeah. So these are the actual rules that are reporting the critical issues. So you can make a rule, and you can decide that the rule is either critical or not by just clicking this button. So as you can see, it's very, very customizable, because you can just write any query. You can define what part of the code it should analyze in a rule. So it's powerful, but it requires a lot of customization to actually get started.
Yeah.
So if you want to get started, especially 𝐂𝐡 can help you much faster.
We do have to mention though that you cannot run 𝐂𝐡 locally. 𝐂𝐡 is a cloud tool.
It's a SaaS tool.
Yeah, it's a SaaS tool. It will primarily run in your CI/CD tool, in your pipeline. You might trigger it manually only. 𝐂𝐡 calls this an X-ray, right? You can X-ray a commit, you can X-ray a code set,
Yeah, but
a change set.
X-raying specific files actually.
Yeah, you can X-ray specific files, and the X-ray will then show you similarly to what NDepend just showed you, right?
Yeah.
So it will give you all of the main hotspots, problem areas, and then you can go deeper onto them. And then it will also grade them, so it will help you sort of triage.
So here it gives some numbers, which I said, like it's not really showing the numbers until you drill down.
Yeah.
So this is the abstract entity persister, you know, and it says, okay, these are really hotspot methods because they have like a high change frequency.
Mm-hmm.
And these are the issues that they're having and the complexity. Now, if I would look up the same type in NDepend has a rule which has hotspots. So it also does hotspots. And it has the types and issues to fix, but let's just look at types to fix. But and here it uses a completely different way to determine the priority because it looks at the depth and the estimate it takes on how easy it would be to fix the depth. So the return on investment is basically.
So if you make a tree. If you make a tree of all the things that are wrong, it assumes that the leaves of the tree are the easiest to start from.
Well, and the one with basically the highest breaking point. So here, this is a great example. It says from its estimates, so it estimates a depth for each violation, each issue, and it's okay. It says like you can fix the depth in 38 minutes. But you're accruing 3 hours and 20 minutes of debt each year when you not fix it. So basically, your return on investment is 96 days, 69 days. But to be honest, like if you're never touching this thing, like why would you fix it? So it pops up at top, but there's no reason to fix it. And I mean, if I
this is a little bit going to the question of 𝗪𝗵𝗶𝗵, why. So it is a little bit like sometimes you need to do things, sometimes not. And actually you need to understand or learn to understand why. And there we are again with, are we there again with coupling and cohesion? What was the original topic about that?
Yeah, maybe we should go back to that.
Yeah.
I think this is sort of an intro into that because that abstract entity persister is an interesting class to show also from a visualization perspective. There's a visualization that helps you identify the cohesive parts in incohesive classes. So that's what I wanted to show. But the why is basically if the maintainability aspect, if you need to do maintenance on that piece of code, or if maintenance is frequently done on that piece of code, then you need to refactor it because it's hurting you basically.
Actually, there's another element to it. Which is clear from the diagram you have in the breaking point. If you just scroll up and down, so we can see the breaking point, right? The way the chart is shaped is a power law curve, or the inverse of it would be logarithmic, which means your general sense of averages doesn't apply here. Because there will be a lot of like long tail small problems that are not worth addressing. They're always in your face, but they're not worth addressing. And then there are a few really annoying ones that span to years, on the breaking point side. Right? And these are actually the other way around. Like we should be looking at which ones have a sort of median order of breaking point and having a lot of depth.
It does, by the way, aid a bit further in the severity. So you also see that the severity of these issues is very low. What is it? What does it say? What's the actual issues that it's reporting on this one? Avoid defining multiple types in a source file.
Yeah, this is a warning, not a.
Technically, you should have prettiers or beautifiers or refactoring tools do these kind of things for you. These are not even worth testing. You can automate those rules, basically. Avoid methods with too many overloads. Yeah, well, that's maybe a bit harder to address, but. It says
It's also C# specific. This is also a library, not an application code base. So libraries are notoriously more difficult because there's rules that are outside of the code base, which is which part of this is backward compatible, which part of this is a breaking change, how was that communicated, when was that communicated. So there are DevRel and sort of governance issues that go into open source projects like this as well.
Yeah. So let's just go back to that abstract entity persister, because here you see this has a breaking point of 3 years and 220 days. So it's somewhere down there. It's not on top. So I like that's what NDepend's not that good at, sort of giving you priority, especially when there's so much.
Yeah.
If you incorporate this in a greenfield project and you pre-select a set of rules, then it's valuable. But in a running project, you should, turn off things, exclude things, prioritize in a different way. So then it takes a lot of time to set it up. And CodeScene you can just plug in, and it will just really extract the painful parts very well. But
is CodeScene actually measuring depth as well?
Not like this.
it's
Because
not
depth for me is so I don't like the word depth, because it's actually no debt you pay back. It's just damage you have caused and you need to repair. It is not like a form of debt, like, hey, we can take some credit somewhere and pay it back over time. It is not the same thing. So we should not be tempted to take debt in this case. Right?
Debt is actually a weird concept, right? Because, for example, debt in finance implies that you owe somebody money, and it is in the bank's best interest for you to never pay it off, because they'll just keep accruing interest. Let's say if you have a bad credit card habit, if we have anybody from the US in our audience, you're notoriously known to be a credit card nation, and if you have a credit card and you start taking on other credit cards to pay off your first credit card, then there's this time horizon when you are diverging from your goal. Like, you will never reach your goal unless you make a giant leap of faith and actually significantly change your financial habits and your financial belief system. The point here isn't so much that you're accruing debt, like good debt, to buy an asset that generates revenue, that appreciates. The point is so that you can analyze whether your habits, you have something that has depth, quote unquote, and you keep changing it often. What you want to analyze that on a time horizon, is the depth getting worse or better? That's really what's the important measure that CodeScene highlights very well. I'm not sure about NDepend, but I do know that ArchUnit enforces that, although it doesn't measure it. I think it's using a similar library than NDepend to create the rules, because there's a clean architecture template for ArchUnit, right? So
I don't know, but there's overlap in that respect, that you can write rules to monitor your architecture in NDepend.
Yeah.
Or you can do it in the test. But in NDepend, you can very easily say, for instance, and then I'll go to this. If I just go to the dependency graph, which is, this is really painful. Let me just show the whole application. I need to go up. So that's what why is it?
That looks dramatic.
Well,
very dramatic.
Yeah, but I'm looking for a button which I can't find right now. I want to go back to the whole application, but let me just see if there normally should be a button application, and then it will just jump. Otherwise, I do it like this. Yeah. But now, so this looked less dramatic because it applies some grouping. It's clustering complex sets. If I do this, like this is the namespace dependencies.
But
yeah, so there is some layering to this. Like this on the right is lower level layering than on the left, but all the red arrows are cyclic or mutual namespace dependencies. which it has a rule on, but every project I analyzed so far has that and has a lot. So there's like a key framework has like thousands or hundreds of thousands of hits. So if you don't do this from the beginning, like you can't fix it later on. But
let's take a look. Take a step back and take a look from a little bit from outside. We had already the experience with TDD and those kind of things. That a lot of, let's say, you need to have, let's say, you need to be quite convincing in your team to make everyone believing that TDD is actually or understanding that TDD is actually giving you some advantage. So you should do that. So in this case now we're looking at something, in my opinion, very complicated. It is something which is not easy to understand.
It's accounting. It's code accounting, essentially.
Yeah, it is, but it is a totally new discipline. So when you're just used to typical programming, typical IDE working, ticketing system, stuff like that, you might think when you see this is overwhelming. I don't do this. I never needed it. I don't know if this was a little bit going to direction of 𝗪𝐿, where he asked why, and I would extend this question with, why should we bother? So you said maintainability. That's actually good. So maintainability is always a part of my strategy requirements. So strategic requirements. So maintainability is a very important quality. So NFR, right? So how can we get people to understand that this is important? So what you imagine, you're on stage. And after this, so you have this as a presentation, and other than in the stream, this is not often the case, but on real stages, people come to you and ask critical questions like, how can I get my people to do this? How can I convince them? What would you say, Ferry?
How do I get my team to take this seriously? Let's say I'm on board, and now I need your help, right? So how do I get my team to take this seriously?
You're sort of good question. I didn't need to do that too much back. I started using NDepend not that long ago myself in a team where I was leaving, but I wanted to show them, at least bring a few things to the awareness, which I had a gut feeling about, which also related to a lot of coupling. I think I realized that often you need to create awareness first before you can even convince people. So I would find it hard to answer that question because it boils down to a lot of fundamentals. And I pulled this one up because I do think it's interesting. So the question is, where is your team in this sort of Maslow pyramid of hierarchy of needs? Because if they're sort of like, oh yeah, it's running in production of it, or it's doing what it's doing, and then like, okay, it works, it's fine. And if you don't experience the pain, it's pretty hard to explain what the pain will be from your own experience.
Absolutely.
I think Dennis can relate to it, that often people come to you when the pain is there. So from I think a coaching perspective, sort of like, okay, they already realize they do have an issue, but it's harder to do it indeed when they don't experience it as an issue yet. That's what I had with this team. Look, it was not leading to direct problems. It was a new code base. But the only thing I did at that point is like just create some awareness. Look, there's tools which can do measurements on quality. This is what measurements mean. I did experience the friction myself. So there were some devs in the team who could relate to it, but it wasn't quantified. So all I did for them was sort of like, look, these are the numbers that relate to the sort of the pain you're having. So if you want to convince a team, you first need to understand where they actually are experiencing pain. People are very good sort of walking around their friction. I think we all know that. It's like, like solve it later. But it's not that they don't know it. So on stage, it's a hard question to answer, because I would need to understand the context first to pinpoint where the pain actually could be.
And 𝐓𝐞𝐡 is a great tool for that, because you can tell somebody, just install 𝐓𝐞𝐡 and check your roadmap, then check if your roadmap is touching a hotspot.
Yeah.
Because the hotspot will throw off all of your certainties, right? It'll throw off your time estimate, it'll throw off your cost estimate, it'll throw off your stress levels in the team, right? And you can check that, right? So if you go to 𝐓𝐞𝐡, I think it's scope. They recently moved things around. I think it's if you go up to scope, I think it's in the scope. System trends, I believe. And component trends. Fourth one. Yeah. There's no components. Yeah. Sorry.
Hang on, maybe I do have a project.
If the demo project has one, then that one would be great.
Let me see.
I need to leave a little bit sooner today, so I would already say goodbye today. But Ferry, I wanted to thank you because it's pretty interesting what you just presented to us, and I think to wrap it up from my side already a little bit beforehand is this is a practical solution to the strategic stuff we're always talking about, right? So we're talking a little bit about that we need to have those things, that we need to take care for maintainability, but actually how? And the hows are more complicated sometimes than we actually think. Yep. So we can have maintainability by, having, let's say, good faith in our work, or we can measure it. So on some point we need that, on some point we don't need that. But I think it's important to know and understand that those tools are existing and you can learn and work with those tools, and there are people like you can help with that. And I think this is a very important thing to know about, that you can determine if you actually need a tool or not. But if you really are into maintainability and you have, let's say, high stakes, then the question is quite obvious, right? So I'm using 𝐓𝐞𝐡, not in the extent of how Dennis might use it or you might use it, but it is a motivation today to see that, how you and Dennis presented that is actually something to dig more or spend more time with. And I think this is important for everyone in the audience as well. You should just start with. It's a little bit like, how do you apply testing or TDD to an existing brownfield project? The question is actually quite easy. Just start with on some point, but don't try to to change anything. Don't try to change everything at once. Just go with the stuff you're actually working on and take a look at it, going step by step. So it is better that you use it, maybe in the beginning in the wrong way, but you start to use it in order to learn it, to use it the right way. You need to get feedback of your changes. Ferry pointed out the time dimension, the temporal dimension, which is extremely important. So you start with on some point, and for example, 𝐓𝐞𝐡 shows you the trend. So do you working towards a better direction, to a more positive outcome, to better maintainability, or actually is someone in the team or some people or some groups actually doing worse without noticing it? So you have something where you can start a discussion with people and say, hey, let's try to fix that. So talk about that. Is that actually a problem? And if yes, let's fix that in the future and try to get this into a more positive state. And for this, I want to thank you, because this is a very good tool on the operational level to fulfill the tactical need to have a good static code analysis, to improve on the principles of coupling and cohesion and similar things, and of course, meet the criteria of the non-functional requirement maintainability and others, of course, substitutability, for example.
Absolutely.
Yeah, great.
It's a maturity thing, and that takes practice essentially. And basically, when you start discussing it, you're up here. So the context really matters. Like what's the kind of project you're building. And if you're working in a SaaS company, you better spend some time on doing these kind of analysis, because they will hurt you over time, because the cost of doing changes will go up if you do not monitor these.
And even if you're coming from like a small to medium business perspective, like which is usually most of our audience, it can be very helpful for you to just one person, without bombarding people with surveys and meetings and estimates and everything. You just as a tech lead, as an architect, as a engineering manager, as a CTO in a startup, you can open up CodeScene and you can check which nature of problems do I have. Is it that my team that is relatively fresh and junior, are they maintaining code that was written by somebody 2 years ago that is no longer at the company? Is that the nature of the problems? Are we, there's also the team alignment analysis in CodeScene, which is amazing if you're into domain-driven design, or if you've read team topologies and you do flow analysis. CodeScene will tell you what your the code basis flow analysis is. If you can show it real quick, if you have a team-based, but I know it. I know it's
license. I think.
I know it's visible in the Team Code Alignment Explorer. That's the one.
I think
that one.
You need a specific license for it. So.
Okay, no, but it is showcased in the React demo page. If you have those open, if you just Google CodeScene demo, it's in the showcase project. Or showcases, yeah. It's in the React demo if you have access to them. Yeah, that one. All right, if you go to Team Dynamics and you check Team Code Alignment Explorer. God damn it, did it turn it off? Can you just look at teams, perhaps? You just look at the teams. The other...
I actually need to go, so I say goodbye and thank you very much.
Thank you.
Then have a nice day.
Yeah, I'd like to spend like the last few minutes on the part I wanted to show on the cohesion in NDepend, also the visualization, because I think that sort of this is very sort of big. So this is a dependency structure matrix. So and this is on a class level. So it puts all the fields and methods both on the rows and the columns. And it will show the usages in both directions. So, and we'll just zoom in a bit on this. So the blue arrows is a column sort of using that. I think the row is used by the column, and the other one, but we can do it. And no, it's the other way around. So the blue ones is the columns using a code element in the row, and the green ones is like who's using that specific code element, which part in the column. So it has this triangulation function, which it tries to put the more often used code in the bottom. So it's triangulating in the sense that that's the code that has a lot of fan-in essentially, and so it layers it basically as much as possible. So here you see, if this is like, it's almost impossible to read, but you see a lot of blue dots on this column, which implies that it's probably a constructor. See, so it's the constructor that's touching a lot of the members. So this is what they call sort of also a mediator. So it's mediating to a lot of members. You could see it similar on class level. So I will show that later. And this is a property, for instance. Let's just zoom in a bit. So this is the entity meta model is used by a lot of functions. Now, what the triangulation does, it will also, you start some squares to see a pairing. These are pieces of code where that are very tight together. So those columns are called by, so the green ones, so the colors, so the methods in the columns and the fields are calling the methods in the rows. And
that's fascinating.
Yeah, it's it's interesting. You can actually ask some info about it as well. I think it will explain you. So it becomes, especially on this level, a bit harder to read. But the squares are an indication of the more cohesive parts in the code base. Because if I use the same dependency structure matrix on namespaces, you would see that the classes within these namespaces should also be more cohesive, like collaborating together. So you will see those same squares along the diagonal. So for these bigger classes, those are hints where you might have small pieces of cohesion that you could sort of extract. So there's a shared piece here, but I believe I once had another example. Well, here's for instance a small one. You know, like with these big things, just start small. You see that there's barely anything else in this column that has blue dots. So that might be an indicator. Look, okay, these fields, you could extract them. So there's here some usage. What is it actually about?
I think the UI needs some work because
yeah, it's also slow.
I'm finding it very difficult to track what the colors mean exactly.
Yeah. But sort of you see that it's hard with this big one to actually do it. Sometimes the graph will tell you better, but holy shit, it's even.
So from a perspective of, if you just zoom out for a little bit, from a perspective of when in my life cycle, if I'm doing TDD, if I'm doing continuous delivery, when in my life cycle would I do this? Do I do this in this sort of refactoring step, analysis step? Am I doing this when I'm sensing there's a mess on my hand? Am I doing this during planned, like long-term maintenance?
Well, if you go back to TDD, I think it's good to have that kind of monitoring in place. You can even run it on a single commit if you're having a feature branch, for instance, but you can run it locally. But you probably have that gut feeling like this is getting out of hand or it's getting too big. And then you run these analyses locally to figure out, okay, how should I decompose this? Especially if you're new to the code base.
Makes sense.
So that's where this could help. If I go into my notes, I might find another class which is a bit smaller, but given the time, I think this is sort of at least gives a hint.
This is great. This is great.
On cohesion, how you can sort of use the DSM not only to find sort of recompose bigger classes, but you can use the DSM also on the whole assembly. Show on and it's linking the columns and
so from the context of, we gave an example earlier in the code example, when a tool like NDepend or a tool like 𝐓𝐞𝐜𝐡 says, hey, this is too complex, it's coupled to, it has a too high 𝐿COM value, or it might be coupled to too many things, or particularly on this chart, it's red. You mentioned one of the first things that you can do is to extract methods, extract variables, sort of separate out functionality.
Yeah.
That is usually an answer to coupling, but it's possible that we do that too mechanically, too naively, and then we lower the coupling problem, but we don't increase cohesion. So if that is a coupling refactoring, a refactoring that manages coupling, what do I do to make sure that that cohesion is also increasing? What do I need to be careful of?
So come again, if you're reducing coupling,
so how do I make sure that the thing I'm extracting is actually cohesive to itself? That I'm not actually making it worse by extracting, like there's repetition going on, or maybe there's coupling going on. I extract it, but then, oops, I actually made the mess bigger. I made the cyclomatic complexity smaller. I made the lines of code smaller. I made the number of efferent couplings smaller. But the thing I extracted is actually also a hotspot. How do I ensure that doesn't happen? Are there any other tools? What do I do when coupling is okay but cohesion isn't?
Well, when cohesion is also always on the class level measured. So it has too many responsibilities. So the thing I can only think of is extracting the single responsibility, but where you can go wrong, and that's where the difficulty is, because often you're extracting something and it has a dependency on a piece,
and then you
that's where the hard thing is.
Yeah,
so
like the data, there is a structural dependency, but not behavioral dependency, right? So I need data from a query, but it is defined in such a way that I need access to the entity manager or some kind of provider that was injected in, and my coupling is actually to the result of that call, not to the callee itself, right? And then you have to decide, okay, am I caching this? Is this a static dependency, a dynamic one, a factory dependency, right? So that's, I think, where most of the hard decisions in refactoring come from, is this sort of indirection of, am I statically bound to this, or am I injecting a function that gives me the thing, like give me the thing that gives me the thing, or do I actually give you the thing, or do I give you a factory function that gives you the thing, or do I give you a cached result of the thing, or are you a representation of the thing and you're actually just a derivative, which is more a functional paradigm? So how do I make sure, for example, I will simplify my ask, I find these problems and I extract two small things. I extract a bunch of small things.
And then you go like in a coupling mess.
I will just have 100 files in my folder, and I will solve the coupling problem, but I now lose track of like what's cohesive, like what are these things.
Sort of what you're touching upon is a set of, is basically you need to take into account proper layering. I think that is
this is the main critique usually on LinkedIn to things like clean architecture, clean code, especially the family of clean architecture and clean code and TDD that Uncle Bob is sort of advocating with his more, let's say, enthusiastic stage presence about, how many lines of code a function should have and how many responsibilities a class should have. And what does responsibility mean? One of the most, let's say, popular criticisms of these kinds of quality movements is that I'll end up with a bunch of classes, two small classes that have 4 or 5 lines of code.
Yeah.
Right, so how do you, like, what is the checks and balances here? How do I prevent that smell from appearing? So that would be shotgun surgery, or that would be that is actually shotgun surgery, right? Is that I end up creating basically a class around every function, and every function that is more than 40 lines of code, I split up into 10 other functions.
You get to the point where you're just creating single function classes.
Yeah, and it's very hard to name them. And then due to the lack of precision in the naming quality degrades. And then I lose cohesion because I get these random thing aggregator function impl classes that then are basically not packaged cohesively anymore.
Yeah. To be honest, I find it sort of hypothetical situations much more interesting if you have a practical example. But what I am feeling in this conversation is that if you have dependencies going all over the place, you want to start thinking, and NDepend is really adamant on that, about layering your code. So you have lower level responsibilities and higher level responsibilities. And there's essentially a hierarchy. So you
can direction of dependencies. So that lower level things don't depend on higher level things.
Basically, NDepend says your code should consist of acyclic graphs only. So it's very it's very strict on it, but it's not that easy. We don't have time to go in like the gist of that. But what you can sort of, if I would show you what you can, how
well, the gist is easy, because I like this math problem, right? So if I depend on you, that's one dependency. If you depend on me, that's one dependency. If we depend on each other, that's three dependencies, right? Because I depend on you and you depend on me, and then there is the pair itself. That might not be cohesive, which means that the more mutual graphs you have, the more indirection between the graphs there are, right? So I might not depend on you, but I might depend on banana, and banana depends on you, and you depend on me. So I'm cyclical. I'm cyclical through banana,
through multiple levels,
and that's the devil, right? And then that's those levels of dependency cycles then, by power law, exponentially increase the cost of change in that code base. Right. So just getting that down, flattening that down, takes you from a logarithmic to from an exponential to a linear space. In at least cost of change based on code size.
Explaining it in the more mathematical sense. This is an example of a layered namespace. So here you see a util class, a helper, which is potentially a bit of a smell, but I did a triangulation here as well, and you can see it's similar in the dependency graph. So this is just configuration, so it's fairly trivial, but here you can clearly see a visualization of lower level classes and a mediator, which is a factory in this case, which you can see it's composing all the different parts of the configuration. But this is a pattern.
Yeah, it looks like there's a builder pattern, and then it has a branch for each of the consumers and producers.
And that's basically a very common pattern. But if you and that's what I find sort of interesting sometimes, especially sort of with juniors as well, that concepts that they understand on a class level that for some reason don't translate to a namespace or an architecture, while it's essentially the same concepts. It's just applied on a different granularity.
Yeah, because you need to define this idea that I have a layer, and then there are other layers that need to be private. It's like I need to not know about them.
Exactly.
Which is very difficult to explain on an architecture level, because the code does this on a file system level, but the architecture doesn't.
Yeah.
Which takes away that guardrail.
That's why you
there's no guardrail.
The only guardrail you have in .NET are assemblies. So I can show you.
And .NET has assemblies, which is great, right? Which is like a second layer to a namespace. Then you can define this assembly depends on that assembly. If you don't declare the dependency, you can't import anything from it.
No, but you can't make them cyclic.
And you can't make them cyclically, which is extremely useful. The same thing applies in Node.js, but this cyclical detection is only done on the NPM level, on the package manager level, if you export your package as a library onto the public market. If you don't do that and you just have like a huge monolith, then you never go through this step, which means that you might actually cyclically be depending on a lot of your internal projects if you never publish them, right? Because it's on the publishing step. The linter is on the publishing step, and you never publish your private proprietary code.
IDEs are not helping you there. You just alt-enter your way through dependencies. You know, it's that's why one reason why I say these tools are very valuable, because it helps you prevent these mistakes. Because even as a senior or a staff engineer, you can't comprehend this like cognitively. It's just you can see like something's fishy. But it's just impossible when you're reviewing code, understand if somebody's making unwanted dependencies, linking layers that should not be linked. So NDepend can do that with rules, architecture texts can do that. And you can use some visualization to analyze it if you spot these issues. Because this is classes, where you see a layering, but the same applies to namespaces. If it's properly engineered, you'd see exactly sort of the same layering. I mean,
you had a layering conversation today on LinkedIn. Do you mind if I bring it up on screen and we discuss it a little bit more in that context?
Definitely, because you wanted to discuss this, so that it made me think like why TDD is not going to help you with that necessarily.
Exactly. So let me get it on screen. Is it okay if I take your screen off of the stage? Or do you want to show something?
Well, I wanted to, maybe it's interesting while you take it up. I'll just show one thing about you saw this whole graph if entity framework, which I just showed. It's like incomprehensible. It's one assembly. So one assembly has advantages because you have less file system operations, these kind of things. But the disadvantage is that you sort of you need then put rules in place for your architecture, and NDepend can, or other architecture tests can take that away. So the graph for entity framework, you see that there's more layering here just because they separated the solution in various layers. But you can still see that the problem, if you look at the core itself,
also exists inside the layer itself.
Translate, and that's what NDepend is trying to tell you. It applies on a namespace level. It applies on an assembly level. You should even on a class level think about that. I think sort of that concept that the layering that basically applies on every level of your code. Like you put one single responsibility within a class, but you also want single responsibility within a namespace or a module.
Yeah.
And so it expands, but the principles are the same.
Awesome. Is there more you want to show before?
No, I just want to show like if you do assemblies, it will help you to a certain extent with layering your code. You just can't screw up
because you have that extra bucket to dimension to help you separate things.
Yeah, so sort of
because otherwise you need to look at the whole picture, and the whole picture might not make sense holistically because there might be too many red lines floating everywhere.
Yeah, so that's why if you can put it in one assembly, but then you can't do without tools. What you sort of here you can say, okay, there's layering in the assembly. Yeah. So that
same thing in TypeScript projects or PHP projects. At what point do you split it? Is this a monorepo with several projects, or is this one project with many responsibilities? Is this a monolith or a modular monolith with multiple deployables, with a single deployable? Like, what are the artifacts and how do we separate them? And a lot of PHP projects, for example, have this like notoriously a lib folder. Is the lib folder part of my project, or is this a lib project?
Yeah.
Is the lib project useful for any other project, or is it only my lib project?
Utils.
If it's only my lib project, if it's only my utils, well, then it's not utils. It's about my project, right? So I hate the misc folders, the lib folders, the utils folders, the other,
It's a smell.
It's a smell. It's an architectural smell, not a code smell. And the architectural smell will highlight cyclical dependencies like these, right? Because it might have
exactly
project might reference.
And if you start analyzing one of those cyclic dependencies, there's one more thing. Let me just show one, because what you can do, you can say, okay, I just want that graph of the elements involved in this cyclical dependency. So the caller is different namespaces. So each caller is a namespace. Sometimes you see just one file in the other namespace.
Yeah.
Just one method in a utils class that is like, okay, so basically just moving that one function, which belongs
to the thing, will increase cohesion, but it's closer to the manipulation point, right? So it's closer to the state it is manipulating.
The code basically belongs together, it lives
and that's
together.
The point with object-oriented programming. You keep mentioning that this is a class-based heuristic, but the whole point of object-oriented programming is to define the types so that they express behavior, not the data. So that it'll force you to hide the data, so the data will be instantiated with the class that incorporates the type of the behavior, and then you just talk about the type of the behavior without talking about the data. The instance will define which instance of data it has, but it wouldn't structurally expose what's inside it and how it is saved, right? So that's object-oriented programming. A lot of people seem to think that object-oriented programming is about inheritance, and it's about shadowing, and it's about abstract classes, and it's about interfaces. That's not actually the case. It's about being able to express behavior with your types. For example, in C, a non-object-oriented language, it is very difficult to express behavior with a type because functions are not typed, right? It's the return values are typed, the inputs are typed, but the interface is not typed, right? So that's the common complaint about C. C++, however, allows you to create those types, but only through templating gimmicks and more complex structures, which are notoriously known for its sort of lack of readability, or sort of overly verbose, almost to the level of obfuscation. Anyway,
yes, you can program some things into a language. I like that concept from Steve McConnell. So yeah, you could program into the language the concepts you're missing in the language.
Yeah.
But it will often lead to other sort of challenges where you do have a lot of boilerplate or these kind of things, because you need to do the same thing over and over. And I think from the object orientation level and the expressing the sort of the behavior, I think a concept that's maybe also worth to address, I don't know if we ever talked about it, is the idea of invariants, and those should be guarded by your class. So that's why you should not expose all these that data.
But it's more that is not a very popular topic of discussion in object-oriented circles.
Yeah,
it always goes to this more functional paradigm of immutability types, right? So invariants, one way or another, leads to this immutability aspect of your type should be immutable, right? So you shouldn't allow state changes. Any mutation should be a new object. And then you get these cohesion problems with the performance freaks who say, well, if you get the cohesion wrong, you'll be creating millions of objects and it'll crash your performance, which is true, but that's a cohesion problem, not a object orientation one. Anyway, let's get the other thing on stage.
The conversation that we were
having. So Michael, wait, I can't have this on screen. It needs to be on the. So Michael mentioned, if you practice TDD very well with discipline, then clean architecture emerges naturally. I also wasn't a fan. Just wanted to follow the conversation. John mentions, and this is where you came in. This is where I pinged you.
Yeah.
John, who's also one of my clients, he says, "Oh wow, as much as I love TDD, not sure I agree with that. I've practiced TDD well. I have had discipline, and the clean architecture definitely did not emerge naturally. It did force better design decisions for sure, but I don't see how that would happen. Now, I agree that clean architecture can help you decouple and improve your TDD workflow. Sure. I've done quite a bit of evolutionary design and never seen the clean architecture just emerge. So it was never intrinsic. It was never a free lunch. This is where I pinged you, because we were talking about coupling in that sense. And you said, I must agree with John. Yes, TDD could help you identify pain with coupling early on. It definitely helped me think different about dependencies and coupling, which is what you showed today with NDepend. But the short answer is the coupling does not imply layering, which is an important trait of clean architecture. Also, clean architecture mostly focuses on a business domain, while layering is a trait you can apply to any code base and on different levels of granularity as well, which is really interesting. I didn't expect that from today's conversation, right? So you went into, so you use these solutions and the natural boundaries of cohesion as signs that there is a layer here emerging, like some kind of, it's not clean architecture, it's not infrastructure or domain replication, like it's not bound to the big tree and then features orthogonally. It is more this sort of n-tiered layer architecture where lower level concepts emerge naturally just by how they are coupled or how the coupling graph.
But that's what I sort of showed you. Like, I rest my case that both Entity Framework and Hibernate, they have a big test set. I mean, I didn't do the forensic to what extent that was TDD. I mean, that's probably very difficult. But there is a large test set. I assume there has been some TDD going on. given it's Microsoft, and I know like 𝗪𝗏𝗍𝐵, he worked on NDepend. He's a pretty well-known developer. So, you know, I'm making some assumptions there, but you see that there's probably pretty good decoupled pieces of code, but it's not necessarily well layered. There's two different things.
Yeah, it might be pointing the wrong direction, or the dependency graph is wrong, or
and sometimes it really depends.
Or to run a test, you need to create a bundle of 7 dependencies that always coexist together, but they have to be orchestrated. You have to instantiate them in the right order, and then A needs B, and B needs C, and C is also needed by A, but A provides a part of D that is needed for B, so that you get these like. So you essentially get the problem that dependency injection frameworks. So dependency injection frameworks are also a 𝐓𝐞𝐝, because what the problem that if dependency injection frameworks are solving is the cyclical nature of your graph. If you have cycles in your graph, the dependency injection framework will figure out what the natural composition roots are. Right, so you can just write a flat config file, and it'll figure out where the composition starts. But that is also a 𝐓𝐞𝐝 if those become too complex, and you're not actually taming your cyclic subsets of the.
I believe that there's DI containers that will sort of at least warn you for that if you're doing this.
Yeah.
So simply say like, I can't do this.
Hopefully, yeah.
Tell me how I can't do this. Especially depending on the life cycle, you know, like sort of.
I mean, you can't do it. You can't do it if there is constructor dependency, but there might just be method dependency.
Yeah.
Right. Yeah. So I can give you null, and you won't call it. It won't crash. But it might be injected through a factory, and then when you do call it, I will give you the instance. So it's possible that you just had to be instantiated, and you're part of that dependency. Then when you call it, you already exist. So you will create it.
You could get weird results if you misconfigure the life cycle. It could create a different instance from the
it could create a scoped one and an application level one, and exactly. And that's also one of the criticisms. You know, back, I don't know if you remember this, but back in the early 2000s, 2010s, there was this huge, you know, Ruby on Rails, MVC everywhere, and one of the main issues was that all of these frameworks generally required acyclical dependency management, which is, well, I need to depend on something that's core to the framework, but the framework instantiates the lifecycle of my application. So once I'm in a route handler, how the heck do I get access to that thing that is more long-lived than me? And dependency injection frameworks emerged. But then you had this problem of, well, when I define a service, I need to make sure that if I'm injecting something into the service to use it in a request, that the service is not longer lived than the request itself, if it's a static dependency. And that was a very easy mistake to do, especially for beginner mid-level engineers with less than 10 years of experience who have never done this kind of architecture, who were not able to identify, well, what am I doing wrong? Like, there are 7 moving pieces. What exactly is causing the problem? And you highlighted today a very good way of finding this problem. In your conversation with John, you then later said, what I suspect is that this tacit knowledge leads to such simplified statements as in just do, then X will emerge, right? Just do TDD, you'll get code coverage for free, and that rhymes. We simply forget what we've learned and know. I notice this when teaching others that I'm operating on a set of fundamental knowledge they might lack. I feel like this every time I'm in a TDD or DDD workshop. Like, it's because they know how to do TDD.
Yeah.
It's just a whole set of other fundamental knowledge that they lack. How to work in a legacy code base, how to refactor an untested legacy code base, how to do repository history forensics, how to identify hotspots, how to estimate without estimating, right? So the whole no estimates movement, right? Because people might ask me, well, Dennis, can we estimate this? And I can tell them, I can't estimate how long it's going to take. I know it's going to take longer than you think because it is touching on a hotspot that code scene marked as critical red.
Yeah.
right? So I know that whatever you're doing is not going to go according to plan, right?
Yeah.
And that always surprises them. It's like, Dennis, how do you know this much? And particularly, how do you know this with this much confidence? Oh, because the data tells me. The data tells me where you cannot possibly be confident. So I can confidently say that there will be issues on these hotspots.
Yeah.
Right? And I'm always, whenever I coach teams like this, they're like mind blown. They're like, Dennis, how can you know this with such certainty? Like, I don't know what the answer is. I just know that it's worth doing more continuous integration here in smaller steps and with the entire team on board, because there's so much uncertainty involved, because 𝐓𝐞𝐡 marked it as a huge uncertainty area.
Yeah.
So if there's more uncertainty, we need to make sure it's minimal steps. You want to plan a week? Hell no. Plan 2 hours. See how that goes. Right? If we can't plan 2 hours, let's not plan a week. And that's usually what gets their attention. And results are usually shocking.
Okay, I think we all made the mistakes, like, okay, let me refactor this thing, and then sort of you're pulling it apart, and you just keep pulling independence, like, okay, oh, this is not gonna work out. I mean, and that's something that's also experience. Maybe you've made these mistakes yourself, and you know that, oh, these kind of problems and the data, if that is there, and that's maybe also one of the answers about the why. Like, why do you want to do this? Well, that's like a risk assessment, essentially. You're asking me to make changes. Like, can I actually even give you in what you're saying, an estimate? So it will help you identify these pain points and sort of manage expectations as well. I'm
more interested in the behavioral psychology aspect. So I have a life coaching background, right? So I'm more interested in the Adrian mentions this a lot, and Calian, if you're still here, the war of art. Right? So the resistance, exactly. Because they will tell me, Dennis, I can't release so often because every 3 months we need to do this cleanup and maintenance thing. And that's serving us well. Because the resistance is that, yes, but you find it painful. So naturally what you're doing is you're batching it together.
Yeah.
Because it takes a long time, so you batch it. What you don't realize is that's making the problem worse, not better.
It's like the mantra, right? If it hurts, do it more often.
We do it more often. But they say, but it'll be more intense. And I say, no, it'll hurt less.
Make
right?
it
So
smaller.
It'll exactly, the pain will be less intense. Oh, but then I need to plan more. Yes, you need to think more, not plan more. Yeah. You need to think more upfront so you can plan less. Right? To move in a smaller step. And I usually see this with branches that are too large and end up in this octopus merge thing, with class hierarchies that are too large.
Relays.
And even the cadence of it, right? You might branch from A, branch to B, branch to C, branch to D, and then somebody does this silly, pull request, like the reverse, right? Merge D to C, C to B, B to A to B. And there's a completely intuitive mistake to make. Right? But they're not pulling it, right? They're not stacking it, as in, I make 7 branches. Well, yeah, just fold A into main, and then B will follow naturally, and then C will follow naturally, and then D will follow naturally without conflicts. And that's the same thing with dependency management. Like, if I made a mess, I can unravel the mess by starting on the other end. I don't need to decompose this, because I made the mess worse.
Yeah.
Right? So, and that's very unintuitive. And the same thing applies with batching. Oh, I have a tech debt here. Google just put out a 5-pager, 6-pager white paper about tech debt. And particularly what they mentioned the most is that tech debt is usually, the most painful part is we need to maintain something, right? So there is a high-level migration involved. We need to migrate something. And that's technical debt, because the migration part is known, it's going to be slow, and it's going to be painful. Or there's a rewrite aspect to it, right? So we need to relearn how something works in order to rewrite it. There's no migration going on, but there is this sort of rediscovery process of maybe it just aged and it doesn't compile anymore. Or the only way to compile it is to boot up a old operating system that still has the library, but we're not allowed to use it anymore because it doesn't pass our security guidelines, because it's end of life, and we're not allowed to recompile it anymore. So it works because we have the binary, but it's not maintainable. And when we have to maintain it, the person who makes that one commit, they are entering a world of pain because they will absorb 2 months worth of maintenance due to one line of code change, right? And those are then highlighted as possible different nuances of technical debt. And this is one of them, like the batching aspect. You have architectural problems. Yeah, like we will re-architect when we're doing something really big in the future, right? Like they're batching it together. It's going to be a big change, so let's batch it together with the other big change. Yeah. And that's the worst thing you can do, because then you're architecting too many things.
and that's where you really need to think upfront a lot, how to decompose that, how can you...
But you can't, because you've never seen it done well. And that's where I usually come in as a coach, because I tell them, of course you don't know, that's fine. Like, don't, right? So I usually have to tell them and calm them down. It's like, it's okay that you don't know the answer to this. You've obviously never seen this done right before, so don't beat yourself up for not knowing the right answer. And then you don't try.
And you don't have to answer immediately as well, right? I mean,
exactly. I just intuitively know that avoiding the pain by batching it together into a larger project is never going to be the right solution, because if we don't know enough about the problem, what we need is a tighter feedback loop. So I need to be able to spin up NDepend and say, what's the biggest problem here? That. Okay, can I solve it in 30 minutes? If I can solve it in 30 minutes, then A, cool, and B, I was right. If I cannot solve it in 30 minutes, that's also cool, because it tells me something more important. It tells me that even though I had hubris in saying that, yeah, sure, I can solve this, I was even wrong about that.
That small thing. Yeah.
Even about that one small thing, I was wrong. Yeah. Right. So with that level of confidence, I have no business estimating projects, roadmaps, right? Because even on the smallest thing that is mission critical, if I can't get the cadence of delivery right, then there's a holistic problem in how I'm receiving feedback, how I'm acting on feedback, what our pipeline is reporting to me, and that is what's worth addressing first. One of the first things I do with my TDD clients is I just tell them, like, do you have a pipeline? It's like, yes. Do you trust it? It's like, no. Okay, then it's time to delete all your tests that you don't trust.
It's fundamental. If you don't have like a pipeline what you can trust, how do you expect to make these small increments?
Exactly. Yeah, and usually conversations are quite spiritual, right? Usually it's, well, what would the pipeline have to tell you so you would take it seriously? And usually it's something in the form of, well, it needs to tell me that the website is down, or it needs to tell me that the revenue stream has stopped, or it needs to tell me that payment is affected. It's like, okay, let's start there.
Start with the parts which basically have the highest business impact.
Exactly. 𝗪𝗵𝗵𝗶 calls this critical user journey, right? So start in the area of critical user journey. And what I like to do is I like to put in code scene, you can configure scope. Yeah. And once you have the teams configured, you can also define which team is working on that scope. And then I can define, this is critical user journey. We're ignoring warnings on everything else. But on these, we send an email to everybody. So that when you make a mistake on the critical user journey, everybody gets pinged. And everybody goes on a short 15-minute huddle call. And you pair program together and we solve it. And that works surprisingly well. To the teams that aren't resistant to ensembling and pair programming.
So you make pipeline. You make the pipeline there. You mean? So if you put in some tests that make the pipeline break on these critical things.
Yes. In a way that requires immediate attention, right? So we're putting the interruption, because it's possible that 7 people are just concurrently coding on 7 different roadmaps, and then we're just basically putting in interruptions on the critical areas that people will take seriously, so that everybody gets together when there's a critical outage. Because otherwise, if this never happens, then they will never take the pipeline seriously. Yeah. If they never take the pipeline seriously, then nothing that we put into the pipeline can be taken seriously. So nothing will be developed seriously. So the tests won't be taken as seriously as production code, because nobody's responding to the pipeline. If the pipeline fails and people are ignoring it, then we have no business in writing tests that people will take seriously.
But that's a bit about the fundamentals, which I mentioned as well.
Yes,
so if you have fundamental understanding about the value of a pipe and the importance of the pipeline. And
when I get onboarded onto a team as a coach, I see two different developers. One developer, they get onboarded, they wait for the tasks, or they go on meetings, they see a broken pipeline, and they're like, okay, well, when I'm done with the meetings, I will ask the team what's going on there. And there is a second type of developer that says, oh, I was onboarded, okay, pipeline broke, okay, I'm gonna go fix the pipeline. They don't even go on anything. Like, they've onboarded, pipeline's broken, okay, let's fix the pipeline. And if people then come in asking, what are you doing? Why are you fixing the pipeline? Well, the pipeline's broken. System says we have an outage, so I'm gonna go solve it. If you think that's a false positive, I will delete the pipeline, but there will definitely be a change. And that's the best kind of developer. Either it's screaming wolf and it needs to be turned off, or it's serious and there's no point having a meeting right now until I resolve this. And that's the best attitude to have. Because then during business hours, you manage the critical areas, make sure the pipeline's green, so that there's no heroics needed like after hours or after like main meetings or things like that. Thomas mentions, Ferry, it was a great session. I learned a lot and my head is exploding. Thanks for making us sensitive and aware that there is some smell in our projects.
Yeah, well, happy I hear this more often. My head explodes. Yeah.
I think it's the NDepend chart.
Oh, yeah, but that makes it even harder. But it's also the amount of information. That's what I mentioned in that post as well. You start explaining things like,
yeah,
holy shit! Sort of, I'm just bombarding them with so much information that's not necessarily directly an answer to their question, but it's essential to explain sometimes. And I loved it as well. I'm happy that I could show that. I found it a very interesting session.
This was fun. I learned something new. I learned about 𝐓𝐞𝐜𝐿, 𝐓𝐶𝐿4, 𝐓𝐶𝐿5. So definitely a shout out to, who mentioned it? A special shout out on today's episode to, I'm just scrolling up on chat, to Danny Gomez-Franco. He mentioned 𝗪𝐶𝐿. We went and looked up 𝗪𝐶𝐿. You then also showed us a code example with 𝗪𝐶𝐿. Thank you so much. Thank you as well, Ferry, for suggesting this topic. You discussed this with Adrian and connected us together.
Thanks for having me.
This was great.
Yeah.
I'm going to show your LinkedIn page again. So why would people reach out to you for consulting gigs?
Yeah,
mostly, reach out to you.
So these technical questions, helping them solve these technical problems. But I also always say, and that's what you mentioned as well, the output is like the code is just a product of the system. So as soon as I look at the code, it's not just you can't look at it in isolation. So I do more than just helping to solve the problems of the code. I question, like, how do you get to this point to begin with, and how can you solve it? So just as you're doing, like, okay, where's the pipeline? What's in it? How are you working with it? How
do you trust it? Yeah.
Do you trust it? What's your approach to making improvements? And then you often pretty quickly touch upon culture as well. So basically, sort of the output, the code base is a result of the culture. So you have to change culture as well if you want to change the results.
You have to change the culture if you want to change the results. I think that summarizes our tech journey and in this stream very well.
Exactly.
I would like to send us off on that note. It's a beautiful summary to the entire episode.
Thanks,
Ferry. Thank you so much.
You're welcome.
I'm gonna roll some gentle rock music, and thank you for being with us today. I had a lot of fun.
Me too. I loved explaining it. The more I do it, the better I get at it as well. So
awesome. You did great. Thank you so much.
Thank you.
To our live audience, a lot of you are not subscribed, and you keep asking me when our next episode is. YouTube, LinkedIn, the newsletter is on Substack. All great choices. Platform of your choice. See you soon. Tomorrow we have an episode with Adrian. I don't know if he announced it yet, but no, sorry. I lied. Adrian is busy. He said we're going to have it on Monday and Wednesday next week. If you noticed, we didn't have an episode yesterday because Adrian had a speaking a meetup speech, and he couldn't make it, and we also didn't manage to announce it. So sorry about that. We are getting used to life happening around us, but we have some great news from that speaking engagement. So you'll be updated on Monday. Thank you so much, Ferry.
Thank you too for having me. See you.
Ciao.